Hello, my name's Dominic Betts and I want to talk to you today about the Entity Framework from the perspective of a Java developer. As a Java developer, you may be familiar with the Java object relational mapping tools such as Hibernate or JPA and the benefits that these frameworks bring to your application, solving the object relational impedance mismatch, reducing the amount of data access code you have to write, and improving the maintainability of your application. In the .NET world, you can use the powerful Entity Framework that's part of ADO.NET and fully integrated with Visual Studio to easily obtain the same benefits. The Entity Framework is around a set of models that describe your data. A store model expressed in the Store Schema Definition Language, or SSDL, to represent the database schema, an entity model expressed in the Conceptual Schema Definition Language, or CSDL, to represent your entity objects and the relationships between them, and a mapping model expressed in the Mapping Specification Language, or MSL, to represent the mapping between the store model and the entity model. These models are defined by using XML schemas, and you can manipulate them by using the powerful design tools built into Visual Studio, although you can, if you want to, work with the underlying XML files directly. At compile time, these models are transformed into a set of classes that define an object-oriented API for interacting with your data, enabling query, insert, update, delete, and other operations on your data. Although the generated classes enable a rich set of data operations from your application code, the Entity Framework also allows you to extend this functionality by customizing the templates used to generate the classes. This ability to customize the Entity Framework is a powerful feature if you have specific requirements and common behaviors that you wish to implement across a collection of applications. Just like the corresponding Java tools, the Entity Framework supports two design approaches. In the database first approach, you generate the model from an existing database schema. In the Entity Framework, you use the EDM generator to perform this task, and then use the designer tools in Visual Studio to tweak the model if necessary. In the model first approach, you build a data model using the design tools in Visual Studio, and then use the Generate Database wizard to generate a database schema. You can contrast this approach with Hibernate, where you use a configuration file to define the mapping between the database and your data classes, or JPA, where you use annotations in your code. Whichever design approach you use, the Entity Framework always uses the three XML models, the store model, the conceptual model, and the mapping model, which makes it easy to understand your solution and which are easy to manipulate using the tools built into Visual Studio. In addition to straightforward mappings from a single table to a single entity, the Mapping Specification Language enables you to define more sophisticated mapping scenarios. For example, mapping a single entity to multiple tables, or implementing table per type inheritance. Unlike Hibernate, the Entity Framework also handles the automatic pluralization and singularization of entity names to make your code read more intuitively. A key feature of any object relational mapping framework is support for fast and efficient queries against the underlying data by using the entity data model classes. Like the Hibernate QL and JPQL, the Entity Framework has Entity SQL, a SQL-like query language for running queries against your collections of entity objects. However, the Entity Framework also allows you to define queries against your entities using LINQ. LINQ enables you to write your queries in a compact, standard notation that's checked at compile time. No more queries as embedded strings in your code. LINQ, introduced in .NET 3.5, relies on Lambda expressions that aren't yet part of the Java programming language. The Entity Framework also makes it easy to enable or disable lazy loading and control when related entity objects are instantiated to tune the performance of your queries. The set of entity classes that the Entity Framework generates from your model include methods and properties that enable you to perform inserts, updates, and deletes in the underlying data store. You can extend the automatically generated partial entity classes with additional custom functionality. However, in some scenarios, you may already have a set of your own custom classes that you want to use. The Entity Framework allows you to incorporate plain old CLR objects, POCOs, into your entity model just like plain old Java objects, POJOs, in Hibernate. In Hibernate, you can use detached objects in n-tier scenarios where you need to pass entities between tiers. Detached objects that have been modified then need to be merged before the changes can be persisted into the database. The Entity Framework can generate self-tracking entities which have a similar purpose, but which are simpler to use. A self-tracking entity maintains information about its state, such as whether it's been updated or newly created. An application can instantiate a self-tracking entity in the middle tier and pass this entity to the UI tier. The data in a self-tracking entity can be modified by the UI tier and then passed back to the middle tier for the changes to be saved into the underlying data store. As an alternative to using self-tracking entities, you can use WCF data services. In this approach, your entity model is exposed as a set of RESTful web resources. A client retrieves an entity by using an HTTP GET request, creates a new entity by using an HTTP POST request, deletes an entity by using an HTTP DELETE request, replaces an existing entity by using an HTTP PUT request, and replaces a subset of the properties of an entity by using an HTTP MERGE request. These actions are defined by the Open Data Protocol, or OData, so you could create a client application with any programming language that enables you to send HTTP requests. Creating a WCF data service is easy because all of the required web service infrastructure is added to your project automatically when you add a WCF data service. With Hibernate or JPA, you'd have to add all the infrastructure yourself. Also, if you're building client applications by using the .NET Framework or Silverlight, you can use the WCF data services client libraries, which provide an object-oriented wrapper for sending and receiving OData requests, which simplifies creating these client applications. To summarize, the Entity Framework is the object relational mapping framework included in the .NET Framework and built into Visual Studio that fulfills a similar role to Hibernate or JPA in a Java application. Whether you're taking a database first or a model first approach to design, it's based around a standard set of models that you can manipulate using the powerful design tools included in Visual Studio. Support for querying with LINQ means much more concise and robust code in your application. In addition to supporting basic scenarios where you need to query and update entity data, it's highly flexible and customizable, enabling you to add your own functionality to entity classes. And it's easy to use in end-tier applications either by using self-tracking entities or by using WCF data services. You can find out more about the Entity Framework by visiting the MSDN website.